So what if I told you that there's an even shorter notation than electron configuration notation? You jump up in the air, right? We're going to move on to the third, final, and what should be the easiest of the notations. It's called noble gas notation. Go ahead and title this next section of your notes. But before I can show you how noble gas notation makes this even shorter, I need to show you where the noble gases are. Look at your periodic table. If you go all the way to the very, very end where you see helium is, everybody put your finger on helium and then run your finger straight down that column. How many squares does your finger touch as you run it down that helium column? 6. Guys, those are them. Look here. Get excited about it. Those are the noble gases. There's 6 on the table. Helium down through radon. Here's what noble gas notation allows us to do. Look here. Aufbau said that we always have to start in 1s. Noble gas notation says, let's start a lot closer to where you're finishing. The reason that this is so long is because we have to start there and go through all this madness to finally get to where we're trying to get to. Noble gas notation says, let's not start here. Let's start somewhere further down the line. It lets you abbreviate a big chunk of the configuration. We're going to get to abbreviate starting at one of the noble gases. The way that we're going to pick which of the 6, remember there's only 6 to pick from, there's only 6 noble gases. We need to figure out where in the notation was the last of the noble gases that was included. And here's what I need. Put your finger on cesium. Put your finger on cesium. All right? Listen to my words. Y'all make this so hard every year, and I hate it. I don't want you to make this difficult. Whatever noble gas is in the row above the element that we're configuring is the noble gas that you're going to pick. Listen again. Whatever noble gas, remember there's only 6 of them, whichever noble gas is in the row above the element that we're configuring is the noble gas that we're going to use. What noble gas is that for cesium? It's xenon. I like the way y'all said that though. No, xenon. All right, and watch what I get to do. Watch. Write xenon, the symbol, and put them in brackets. Now check this out. Here's what that does. It's beautiful. By doing that, we have assumed all of the configuration up to xenon. Instead of writing 1s2, 2s2, 2p6, instead of doing that, by putting xenon in brackets, we've said, hey, everything before xenon, plus, exactly right, if you put your finger on xenon's location on this table, find it. Find xenon's location on this table. All right, he's at the very end of 5p. Do you see how xenon's at the very end of 5p? Okay, so xenon is everything up to 5p. Then what comes after 5p? For cesium, 6s1. There could be a 6s2, but that would be radium. Oh, I'm sorry, barium. Bring my blank. That's it. This is the noble gas notation for cesium, and it should be your most favorite notation in the entire world, because that is a ridiculous amount of not writing anything. I didn't, because you'll have to write all those arrows on the test. But sometimes you won't have to either. Listen again, though, because I know y'all get really thrown by this for some reason. All right? All noble gas notation lets us do is pick a noble gas and start from there instead of starting at 1s. Let's do another one. Find bromine. Find bromine on the periodic table. Use BR. Do my brother. How many electrons does bromine have? He's got 35. So, if we look here, quit working. If we were doing orbital notation, I'm going to keep saying these names because you've got to get the names of the notation straight in your head. If we were doing orbital notation, I'd have to draw 35 arrows. If we were doing electron configuration notation, I'd have to draw a bunch of exponents that added up to 35. But in noble gas, we need to pick one of the 6 noble gases and then just start from there. Now remember, the way we're going to pick our noble gas, bless you. Hey, you've made it into 2 consecutive videos with sneezes. Doing it on purpose. If you look at bromine's location, remember, it's the noble gas in the row above him. What noble gas are we going to use for bromine? Argon. Put him in brackets. There he is. And now we get to start from argon. All right, so whatever block comes after argon's block, and it will always be something S. After your brackets will always be something S. It has to be. What will it be for argon? What comes right after argon? 4S. Does everybody see? Tell me if you don't. Does everybody see why 4S will be the slope start? Yeah. All right, and now it becomes electron configuration notation. All right, how many squares live in 4s? There's 2 of them, or S has 1 orbital, and that 1 orbital can hold 2 electrons, however you want to look at it. But we're not to bromine yet, so we do have to keep going. What comes after 4s? 3D. All right, does bromine live in the 3D block? No, he doesn't, so let's fill him up. 3D contains 10 elements, yes? What comes after 3D? 4P. Does bromine live in the 4P block? He does. Of the 6 elements that live in that block, which one is bromine? He's the 5th one over. Or, if we were back to arrows, P's got 3 orbitals, and it would have looked like that. Because that next arrow would have brought us to that next noble gas in this case. That's the noble gas notation for bromine. If you still really like checking your answer, you can still do that. See that number 35? He's still really important. Watch how I check it. 5 plus 10 is 15, plus 2 is 17, plus argon's atomic number of 18 equals 35. That number plus that number plus that number plus this guy's 18 is the electrons that he's carrying with him, still equals that total number. So you can still check your answer. Do the noble gas notation for titanium, and we're done.